Hello, today we're going to be talking about the degree of a function, and we're also going to be talking about how to find out if a function is odd, even, or neither based on its graph. Okay, so we're going to start off with that degree, and let's take a look at our definition here. And it says that the degree in a polynomial function is the greatest exponent in that function. Okay, so in example 1, we're going to look at x squared plus 2, x squared minus 2. In all cases, the highest exponent is a 2. So the degree there is going to be 2. Now, what is the degree? How does it help us? Well, it tells us the max solution a function has, and it also tells us the max number of x-intercepts. Let's look at that first example. So our first example here of x squared, that's what x squared looks like. Notice how many x-intercepts it has. It has 1. Okay? So x squared tells me it can't cross the x-intercept or the x-axis more than twice. And in this case, it only crosses it 1 time. Now, if we take it to the next one, x squared plus 2, that's actually the same parabola, just shifted up 2 units. And it looks like this. Notice it has 0 x-intercepts. So the degree doesn't tell us exactly how many we got. It tells us the maximum number. It can still have 0, 1, or 2 in this case. And then how can we see it with 2? Well, if I go back to the original parent function and I shift that parent function down 2, I get x squared minus 2, which looks like this. And notice now I'm reaching my maximum number of x-intercepts of 2. I can't get any more than that out of a basic parabola. So it either has 0, 1, or 2. Now, if we change this function to something like x cubed, we can now have 0, 1, 2, or 3 x-intercepts. X to the 5th can have up to 5. And then, of course, as you go further and further along, x to the 99th can have up to 99 of those. All right? So that's what we mean by it saying it can determine how many x-intercepts we have. The number of solutions is pretty much the same thing. It's talking about like if you let the function equal 0 and solve, you're basically working with the x-intercepts again. Now, how does the degree of the function change the shape of the graph? And so specifically, we're going to focus on the degree being odd or even. Now, I'm going to make a quick note here and tell you that when I say, well, there is a difference between the degree being odd and even and the function being odd or even. A lot of times students get those confused, and it's understandable because you're using those terms, odd and even. But the degree being odd and even is different than the function being odd or even. We're going to talk about both of those in today's lesson, and we're going to start with the degree. Let's go over to Desmos so we can kind of see what's going on here a little bit easier. So I'm going to go and type in the function y equals x squared. Whoops, not like that. Let's hit shift and then 6, that's our caret key there, and put in a 2 right there. That gives us y equals x squared. Change that to, let's backspace here and change it to a 3. That's x cubed. So that's your odd degree. Let's look at another even one. Change that to a 4. Okay, now change it to a 5. 5 is odd. Change it to a 6, an even number. Change it to a 7. And I want you to look for that pattern there of what the function looks like. Now remember, x to the 7th, that right there could have that polynomial could have up to 7 solutions. It doesn't here. You know, it looks like, at least I don't think so unless we zoom in and see it squiggling somewhere in the middle. But it's not going to, but it can have up to 7 depending on what's written after it. Notice if we put other things beside it, like if we say plus 2x minus 4, x cubed, it starts to change the way it looks. And notice we get more intercepts here. So it can have up to 7 because the degree of this polynomial is 7. It's the largest exponent present there. In this case, it has 1, 2, 3, 4, 5. At least it looks like 5. Let's zoom out, see if it crosses any more. Looks like there's going to be 5 intercepts there. Now, let's go back to just the basic old y equals x to a number here. I'm going to backspace at 7. I'm going to show you a little trick in Desmos. We're actually going to change that to a b, just a lowercase b. And notice it asks us, do you want to add a slider? Yeah, who doesn't like a good slider, right? So we're at a slider there, talking about hamburgers. And it goes from -10 to 10. And basically, right now, b's value is 1, so you see a linear function there. If I change b to 2, now you see y equals x squared. So I want to change this so that it starts at 3 and goes up to an odd number like 37. And by default, it's going to count in increments, I think, of a tenth. So it'll go from 3 to 3.1, 3.2, and so forth. But I don't want that. I want to just count odd numbers from 3 to 37. So I'm going to count by 2's. So it's going to go 3, 5, 7, 9. And that's what the step value is. It's basically asking, what do you want to count by? I'm going to put in a 2 there. And now as I drag this, currently that's what x cubed looks like. If I slide it over one increment, it goes to x to the 5th, then x to the 7th. And as I drag it out to x to the 37th, we can see that it goes to more squared off type look to it. It's still a little bit curved. If you were to zoom in, on the right you can zoom in and see that it still kind of curves some, just not as much as x cubed. And if you ever want to zoom back out to the default zoom, hit the home key here on a graph. Sometimes it's easy to get like lost, like where am I in the graph? If you hit the home key, it takes you back to the default zoom. So notice it comes from -infinity on the y values and exits on the positive infinity for y. If we now switch this to an even value, so let's go from 2 to, let's do 98 this time. And, oh, not step by 98, step by 2 still, and we're going to go up to 98. So now as I drag this, notice there it is. Let's zoom in again. There's our basic x squared. And as you increase, just with evens, that's what the function looks like. So graphically speaking, we say that whether the degree is odd or even will depend on whether the function looks like this or whether it looks kind of like this. It goes to -infinity and then exits out in positive infinity. So that will change things there, and we know as this gets larger and larger, things get more squared off looking. Now it doesn't always, just because it's raised to a +2, doesn't mean that the graph always goes to positive infinity and positive infinity. You could put a negative in front of the x, and we'll get more into this as we talk about transformations, and flip it. So it's like this, right? Same thing with x cubed. It's not always like this. If you put a negative in front, it's going to flip things around. So those we'll talk about in transformations. What I want you to see here is that the degree of a function will not only tell us the amount of intercepts we have, or maximum number of intercepts we can have, it can also tell us a little bit about the shape, whether it goes both ends point up or both ends point down, or whether one end's going to be going up while the other goes down. Okay? So even, if it's got an even degree, both ends are either going to point up or both ends are going to point down. If it's got an odd degree, one end is going to go up and one's going to go down. And we'll learn as we talk about transformations how to figure out which end goes up and which end goes down. But I want to show you, the reason why I'm telling you anything at all about degrees today is because I want you to understand the difference between the degree being odd or even and the function being odd or even. So the degree being odd or even, graphically speaking, just tells us whether they both go up, both go down, or one goes up and one goes down. If we look at the actual, function being odd or even, that's something totally different. So let's take a look at that. So it says a function can be considered odd, even, or neither. And this is not the same as the function's degree being odd or even. All right, let's look at first what odd, even, or neither looks like graphically. So for instance, if we have just x squared, here's our graph of x squared. And here's two keynotes you need to know about it graphically, whether it's odd or even. If it's even, then it's going to be symmetrical about the y-axis. And if it's odd, it's going to be symmetrical about the origin. And we'll explain what that means here in a moment. So about the y-axis means this. Here's our y-axis, right? We can take this x squared and fold it in half right on the y-axis. And if you were to hold this up to light, it should match up perfectly, kind of like that butterfly look when you do an ink blot or something like that. So these match up perfectly. So this is an even function. Now, if it's odd, we say it's symmetrical about the origin. That's not always, people don't always remember what that means when they're coming from geometry class. What you can think of it is this. If I were to take this and rotate it 180 degrees, it should look exactly the same as the original. And in this case, it doesn't look exactly the same as the original. So this is not an odd function. It's an even function. Okay? Let's look at our next example here. We're going to stick with these x squareds for just one more example. We've got x squared minus 2. Now, if I were to fold it in half, does it match up perfectly? It does. So x squared minus 2 is an even function. Let's look at x cubed. Move this so I can slide the paper up. If I look at x cubed, that graph looks like this. Now, if I fold this in half on the y-axis, it's not going to match up. So it's not an even function. Let's take a look and see if I turn this completely upside down, if it looks exactly the same. So here's x cubed. I've got 2 of them. And I'm going to spin this one 180 degrees. And the question is, do these still look exactly the same? And they do. So this is considered an odd function. Okay? So if you can turn it upside down and it still looks like if you were to, like you just graphed it originally, it's an odd function. Let's look at our next one. It's going to be x cubed plus 3. So x cubed plus 3 is the same thing as x cubed. It's been shifted up 3 units, and it looks like this. Notice we're crossing right here. It's obviously not even, because if we were to fold it in half, it wouldn't match up perfectly. So evens out. Let's look at odd. So I've got a second one already made here. These are the exact same graphs. If I were to take and turn this 180 degrees, does it look exactly the same as this one? And in this case, it doesn't, because notice this one crosses at positive 3, and this one right here is crossing at negative 3. So it's not the same. So it's not even, because when we fold it in half, it doesn't match up. And it's not odd, because when I spin it 180 degrees, it doesn't cross at the same spot. So this one is neither odd nor even. And I think this is where it gets confusing for some students, because at some point they've learned or they've thought that the degree being odd meant the function is odd, and it's not. And you're like, why is that important? Why are we even going over this? It will have its importance later as we study functions. There is a reason why we go over odd, even, and neither here. But just keep in mind that that shift right there does affect this function from being odd. Let's look at the square root of x. Now, the square root of x is the positive root. It does not have symmetry over the y-axis. And obviously, when I turn it 180 degrees upside down there, it looks like it's going into quadrant 3, not in quadrant 1 like it originally was. So this one is also neither odd nor even. All right, let's look at our next example. Our next example is going to be x minus 2 quantity squared. So x minus 2 quantity squared looks like this right here. Now, I've got it written out 2 different ways here because one is foiled out. Sometimes we'll see a function like this, and then sometimes we'll see it like this. This is a nice, easy way to graph it if you know how to graph it with transformations. I just took x squared, and that means shift it to the right 2. Okay, we'll learn that in the next couple of lessons. This is what you could see it written out as a trinomial, but notice the degree is still 2 here. That's the highest exponent. Either way, when I'm looking at this graphically, is it odd, even, or neither? Well, this time, notice when we went back to x squared before, it looked, well, here's x squared minus 2. I have it handy. When I fold it on the y-axis, it still matches up, even though I shifted it down 2. But if I look at it, shift it to the right 2, that does change whether it's even or not. Because now if I fold it on the y-axis, it's not going to match up. It's not if the function is symmetrical, it's if it's symmetrical about the y-axis, which in this case it's not. Also, if I turn it 180 degrees, turn it upside down, it doesn't look the same. So this one is neither odd nor even. Let's look at the absolute value of x. So this is the absolute value of x graphed. In this case, what do you think is going on here? Obviously, if I spin it upside down, it's going to be looking like an upside down V, so it's not going to be odd. But if I fold it along the y-axis, it's going to match up perfectly. That makes this an even function. Next, let's look at the absolute value of x shifted down to. There's the absolute value of x, and we're going to shift it down to, so it looks like this. Once again, if I turn it upside down, it's not going to look exactly the same. Here, I'll show you. See, if you turn it 180 degrees, it looks like that. So it's not odd. But if I were to fold it on the y-axis, that does work, so it is even. And I'll do it for you here. Let's see. Let's fold this on the y-axis. And you can see how it's going to match up perfectly there. Okay? Let's look now at x minus 3, or the absolute value of x minus 3 plus 1. So the minus 3 takes the absolute value of x and shifts it to the right 3, and then the plus 1 shifts it up 1. It looks like this right here. Notice now if I turn it 180 degrees, it does not look the same. You're down in quadrant 3 now instead of quadrant 1, and the function is decreasing. Well, not decreasing, but it's pointed towards the negative values. And then if we fold it on the y-axis, it doesn't match up perfectly. Not even close to being perfectly. So this one is going to be neither. All right. One more example here. Let's look at y equals 2 to the x. So the 2 to the x looks like this right here. And hopefully this one is an obvious one to you that it's neither, but I just want you to start seeing different functions, different parent functions, so as we get into parent functions, these things aren't so new to you. If I turn this one 180 degrees, it looks like this. That throws out odd. And if I try to fold it on the y-axis, it's not going to match up, but I'll show you just in case you don't believe me. There it is. Doesn't come close to even matching up. And so this one is going to be neither. And my battery just died. So that's on that camera, the battery died. So that gives you neither for that one. And I think that pretty much wraps it up. Now we are going to talk about how to find these algebraically. But for right now, for this video, I want you to see what it looked like graphically, whether the function was odd, even, or neither. And then we're going to do a small investigation to see what makes it, how can we determine whether a function is odd, even, or neither algebraically. Okay? So try out the problems. Let me know if you have any questions. And thanks for watching.